Okay, hello everyone. My name is Brian Tadi. I'm from 11 Oxford, and the video is about to do the midterm extra score S or S1 for physics. Okay, in this video, I will explain about uncertainty, one of the topic that I've been learned in this half of the semester. Okay, in this uncertainty, firstly, we will talk about the experimental uncertainty that usually happens. Is divided into two. The first one is random uncertainty. This is like so limited. It's like how this actually usually happens by the people, the person who uses the 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 tools, or the wrong result happen have affected by the equipment. And then the second is systematical uncertainty. This is happens by the wrong setting in the tools. That's why, and there's there is a solution for the for for there is some solution for those from those errors. For random errors, we can do like repeating the measurements, and then we divide it as how much we repeat the experiment, so we can get the average at least for the measurement. And then for the systematic uncertainty, which is it's happens because of the tools, so we need to reset, or as shown here, we need to recalibrating the instruments. And then from these errors, we can see another aspects in in uncertainty, which is precision and accuracy. The first one, precision. Precision in Indonesia, we can say that it's presisi. That's why it's mentioned how tightly the group with the data is, like how each of the data is similar or not similar to each other data. Or in Indonesia, we can say that bagaimana sebuah data itu bisa sama dengan yang lain atau tidak, apakah data-data yang ditujukan itu mirip atau tidak. And then the second is accuracy, like how close our data is to target value. Is the data is targeting the exact that we expected value or not? Like we want to get like 10 milliliter, but the measurement we get like 10.1 or 10.5, or maybe just like 9.7 or something. That's why we really care about the precision and accuracy, especially in physics. As we can see here, there are some diagrams that maybe can help us to understand more about precision and accuracy. The first one here, we can see that this is where the data is precise and also accurate, where all of the data is targeted or reached the magnitude that we expected for. Like here, it's precise and accuracy. Yeah, all of them is precise. Like they were similar mostly, or there is no difference between each other, or just like little difference. They are also precise because they were similar. And then accuracy because they reached the main target. And the second one here, it's precise but not accurate because they were similar each other, but it's not reaching the target that we want. And then the third one, we have it like it's not precise but still accurate. Yeah, it's near to the target but not similar to each other. The last one is not precise and not accurate. Of course, it's not reaching the target and it's not similar to each other. As you can see here, like John is not precise. The John is precise but not accurate. Like the target is 2.7, but John saw the data is 2.9, which is not accurate to the target, but still it's precise because it's similar between each other. Different with Mike, even if it's 2.701 and 2.699, it's still the same. All of the Mike's data is still similar with each other. As we can see that Mike is precise and accurate. And then that's why in physics we need like one of the rules that we use we always use to define, or we can say that we reported the measurement. Like we always have uncertainty. That's why we need the solution. How we can rewrite it? Here we have in this formula we have mean value and uncertainty. Like mean value is the, if it's averaged, so it's the mean value, and then the uncertainty, that it's the probability that it will increase or decrease. Like here it can be maximum value, like from 4 to 5 it can be added by 0.3 equals to 4 to 5.3. Meanwhile it still got the minimum value, which is 4 to 4.7, because 4 to 5 minus 0.3. That's why in this formula we get like percentage uncertainty is equal to uncertainty over mean value times by 100%. Like here we have the uncertainty is 0.3, and then the mean value is 425. So it's we divide 0.3 by 425, and then we multiply it by 100%, and we get like 0.0%, 0.07%. Okay, in this uncertainty also we divide it into some type, some type I can say. The first one is addition. Okay, this is kind of similar, addition and subtraction. And then we have also multiplication and division, and then the last one is the power, about the power, like the power of 2 or power of 4, like something like that. We directly jump to the first one is addition. Like when we have like when we have to combine, like we added one thing to the other thing, when we want to combine between one uncertainty to the other uncertainty, we just add both of them. Like here the first uncertainty is 2 and then the second one is 3, so we just combine them and we get the final uncertainty is 5 Newton second. And then still we need to count the main value. We get the main value here, we just need to add both of them, and we got 162. Still when we need the percentage of uncertainty, we have to divide uncertainty by the main value, and then we multiply by 100%, and we get here 3.1%. And then subtraction, it's kind of similar, but it's kind of similar with this addition, which is only different on the main value. The main value we got here, the first one is 105, and then the second one is 112. It is kind of like the difference between them. So when we got to find the delta, I can say, so we decrease the second value to the first value. Here we decrease 112 by 105, and we got 7 gram. And for the uncertainty, it's still the same with the addition, which is we add both uncertainty from the first value and the second value, and we got 2 grams. So the mass of the liquid that's mentioned here is 7 plus or minus 2 gram. That it can be added to 9 gram, or it less than and become 5 gram. And here the next one is multiplication of multiplications. And here for the main value we need to multiply them. The first main value we need to multiply it by the second value. Like here we got 250, and then 18,000. We multiply them together, and we got like 4.71 times 10 power of 6 meter. And for the uncertainty, we need to subtract both of the value from the second value. We need to the first one we need to from the for the result from that we got from the value that it's 4.5 times 10 points times 10 to the power of 6 meter. We need to find the maximum value and then the value itself. The maximum value we get like the uncertainty is the facility is um like we got here, it's 4.71, right? So we decrease the maximum value to the value. For the value 4.5, the maximum value 4.71. So we decrease 4.71 to with the 4.50, and we got 0.2 times 10 to the power of 6 meters. That's why for the distance we get 4.50 plus or minus 0.2 times 10 to the power of 6 meter. Yeah, and for this multiplication is actually the same for the division. When we want to divide two values that it has uncertainty is the same, like we just need to find the uncertainty by use the maximum value and minus the original value itself. And for the uncertainty we also get directly with that. And then uncertainty and values raised to a power. Yes, this is related to the power. Like we got here, like the example is about the kinetic energy. We know that the formula is half times mass times velocity square. Yeah, you know what? The power here is square. It's from with velocity is the one thing in the formula that has power is only the velocity, which is square. That's why here when we want to find the percentage of uncertainty, we got to find the percentage of mass before, and here we got 1.6%, and then the mass we got 4.2%. For the uncertainty we need to as I mentioned that before, the thing, the value that have power is only the speed, the velocity. That's why when the power is the velocity here is half to power, so we need to what can I say, it's not duplicate, but we need to double it for the velocity. So for the percentage of certainty, as the usual, is the first the percentage of mass and then the percentage of speed. But here, since the speed is half square power, so we need to double it. So it's here percentage of mass added by 2 times of speed. We got here 1.6 plus 2 times of 4.2%. It's equals to 10%. And here the maximum value we got here is 5,000 joule, and then the uncertainty we need to decrease maximum value by the value itself. We got 500 joule. That's why the kinetic energy is 4,500 plus minus 500 joule. Yeah, maybe that's all for the uncertainties. And then precision accuracy, and also about the errors. That's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.